Hello and good afternoon, CTS265, Section 840 students for the Fall 2016 semester at Anne Arundel Community College. This is the CCNP route course, and this afternoon's video tutorial is going to be on Lab 7.5, where we're going to be taking a look at multi-protocol BGP. So if you're following along, I'm going to be kicking off at step number 2 here, where we're going to set up EIGRP. So I've done basically sort of a hand-drawn rendition of what we've got here. We've got the International Travel Agency, who's going to be communicating with the ISP, and router 2 is sort of that connection point here, right? So we've got gig 00 up here on router 1, connecting to FA01 down here on router 2. So we need, because we're going to be doing an iBGP peering here on ITA, so we're going to need reachability to the loopback addresses. So as we've seen in previous labs, you could use static routing, but remember, this is our autonomous system, so we're going to go ahead and use EIGRP to facilitate that in this activity. Specifically, I'm going to go ahead and use named mode. So I'm on San Jose 1. Let's get into global config here and say IPv6 unicast routing. Whoops, unicast routing. And then router EIGRP CCNP. Address family IPv4 unicast autonomous system 1. And then network statements 172.16.0.0. Whoops, 16.0.0. And then 172.17. And this is going to cover both the links between San Jose 1 and San Jose 2, as well as the loopback addresses. Now, let's also set the router ID. So EIGRP router ID, they want us to set it to 2.2.2.2, but then we also need to do EIGRP for IPv6. Now, remember, we're using named mode here, so there's no need to go under the interfaces and say IPv6, EIGRP, and then the autonomous system number. So address family IPv6 unicast, whoops, AS1. We're going to see that what happens, remember with name mode, is that every interface with an IPv6 address is automatically going to have EIGRP enabled for that interface by default. So in fact, if I say do show IPv6 EIGRP interfaces, you can see all I needed to do was type in address family IPv6 unicast AS1, and boom, all of these interfaces are now running EIGRP. But we need to set the router ID, so EIGRP router ID again to the 2.2.2.2. And that is pretty much it. If we wanted to do anything, like you can see it's running on fast Ethernet 01. Now that's the interface that goes to the provider. So if I were to say AF interface, fast Ethernet 01, and shut down, I'm not shutting the interface down from an iOS perspective. I'm simply shutting the EIGRP process from running. So do show IPv6 EIGRP interfaces. Now fast Ethernet 01 is no longer running the process, and that's what we want, right? We don't want the process to be running on the link that's facing our provider. All right, so now what we're going to do is we're going to go on to San Jose 2, which is over here. Oh wait, that's not San Jose 2. I apologize. That is San Jose 2. All right, so we're on San Jose 2, and we're going to do much the same thing. We're going to get into global config, IPv6, unicast routing, router EIGRP CCNP, address family IPv4 unicast AS1. And then let's get our network statements in here for the 172.16.0.0 and network 172.17.0.0. And you can see the adjacencies are now coming up. So if I say address family IPv6 unicast AS1, do show IPv6 EIGRP interfaces, we'll see that, look at that, we're actually running and exchanging. We've got an adjacency here that's running EIGRP, and so do show IP EIGRP neighbors. There we go. There's our neighbor relationship. Okay, so we've got EIGRP configured, and let's see, step 3 now. So we're going to jump right into the multi-protocol BGP, but we're going to do it on the ISP router. Well, the ISP router happens to be this router here. And let's go from user exec to privilege exec into global config, where we're going to say IPv6 unicast routing. And now we're going to say router BGP 65100. We're going to set the router ID, BGP router ID, to 1.1.1.1. And we want a neighbor statement with the sole router that we are neighbors with here for the International Travel Agency in AS 65000. All right, so at this point, we're not actually, it doesn't look like there's going to be, well, the network statement comes later on here, but I'm also going to do this. I'm going to say BGP log neighbor changes and no BGP default IPv4 unicast. So we need to activate everything. All right, so what's our BGP section look like? So do show run section BGP, and there we go. So let's get into address family IPv4 unicast, and we now need a neighbor statement down here that's going to say, and actually, did it do that already? It did. So it had already, we had already put the command in there in the global config area. Then when we did the conversion, it puts the activate here for us. But subsequent neighbor additions are going to require you to manually come in and manually activate this IPv4 peering with that address family IPv4 and then the neighbor, the IP address of the neighbor, and the activate statement. So we've got that in there. Let's add the network statement in for 10.0 or 10.1.0.0 with a mask of a /16, right? 255.255.0.0. The activate statement is already in there, so we're good to go. And now we're going to go ahead and say back out address family IPv6 unicast, and we're going to add in a network of 2001 db8 colon beef colon 1 colon colon /64, and then now we're adding a neighbor statement in again. Now this is interesting, right? Because we're going to say 192.168.1.2 activate. Now, what's interesting about this is we're not doing dual stack here. We are leveraging the existing IPv4 peering so that we have a single BGP peering process with IPv4, but we're using that transport, that IPv4 transport, in order to facilitate IPv6 connectivity. So the passengers, right, the passenger protocol that are riding inside the IPv4 transport truck or bus is going to be IPv6. Now, we also know that we need 168.1.2, the next hop, and they have us add this in right away. Route map is going to be, we'll just put next hop for NH in the outbound direction. So what we're going to have to do is we're going to have to change, or I should say change, we're going to have to create the route map that's going to get added here. So let's go ahead and do that. So we're going to say route map NH, and I hit enter. And remember, by default, it's permit 10, right? So set IPv6, not address, but next hop. Now remember, I'm setting the IPv6 next hop to be my IPv6 address on my interface. So if we pull this back for a second, do show IPv6 interface brief, it would be this gig 00 interface, because we're setting the route map in the outbound direction, which means for all of the NLRI, the network layer reachability information that I'm originating on ISP for IPv6, all of that NLRI, and right now it's that 2001 db8 beef 1 colon colon /64, so it's going to cover the loopback 0 and loopback 1 NLRI. When that NLRI is sent in an update message over to the International Travel Agency, I will be setting the IPv6 next hop to this interface address, which is on my router, because again, I'm giving the International Travel Agency that routing information. They need to know, since this is 6/4, they need to know when that update comes in here, what is that well-known mandatory attribute, the next hop. We've seen what happens when you don't set it. You see the address colon colon fox 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 colon 172 dot whatever, or I mean whatever the address would have been. So we'll say 192 dot whatever dot whatever dot whatever, where you get this IPv4 address embedded into the IPv6 address. The problem is that that address doesn't exist. And so router 2 is not going to say that that's the best route. You're not going to see the greater than sign because it can't resolve a next hop that's got an IPv4 address embedded in the IPv6 address. It's not going to work. So we need to make sure that when we're advertising that NLRI, that IPv6 NLRI over the v4 transport, we have to sort of rig things up so that it's going to function properly. Because if I were to come over now to San Jose 1, and you can see we've got the neighbor adjacency is up here, so do show, and actually that's EIGRP. I haven't done the BGP piece yet here, so I'll tell you what, I'm going to leave the route map off for right now, because we're going to take a look. We want to see what it looks like when it's wrong. That way you can identify that easily. So we'll come back to the route map. So let's get on to San Jose 1, router BGP 65000. No BGP default IPv4 unicast, right? We need to manually activate things. BGP log, neighbor changes. And then we are going to set the BGP router ID. They're asking for the quad 2s. And now let's go ahead and say neighbor 192.168.1.1. That is the Evil Corp ISP IPv4 address with whom we are, with whom we are establishing the peering. Right, so we've got it set up, but remember, we haven't done any of the IPv6 work yet. And the 192.168.1.1, is that the directly connected network here? Do show IP interface brief. Absolutely. So that is the directly connected network. So we don't need to change the update source. We certainly don't need to what was I going to say? We don't need to the update source, the multi-hop or disable connected check, because this is directly connected. However, do show run section BGP is going to show me that we have yet to activate this. And so this is the difference right here between what I did earlier, which is do the neighbor statement before I type in no BGP default IPv4 unicast. When I add the neighbor statement in first, then say no BGP default, it's already activated for me by default, right? That's what's happening. So when I say no BGP default IPv4 unicast, and then I add neighbor statements, and now I need to go into address family IPv4 unicast and say neighbor 192.168.1.1 activate. And what we should see is we should see that this BGP peering should pop up here. And we'll give it a second, and there we go. So now let's go ahead and take a look and say do show IP-BGP. All right, and you can see that that is the only prefix that we're learning about for IPv4. But what about a do show IPv6? Or actually, I'm sorry, not do show IPv6. Do show BGP IPv6. And unicast. Oh, so we have not, no, it should be good. We should see, why am I not seeing that? Give me a second here. Okay, we've got it set up here. Did we not activate? Do show run section BGP. All right, we've got it activated. I'm wondering if it's the route map statement. So let's do this, router BGP. So I have this route map here, but there's no route map that exists that's named NH. And I'm wondering if that is causing the update not to show up over on the other side. So let's do this. We'll say router BGP 65100, address family IPv6 unicast, and then no route map out. So let's pull that out right now. Do clear IP-BGP star out. Let's come back over to San Jose 1. Do show IP-BGP. All right, so we see that, and then show BGP IPv6 unicast, and we are not seeing that IPv6 advertisement yet. And I'm wondering, we should be seeing that. All right, let me double check this here and make sure that I'm not overlooking something. All right, so the network statement 2001 DB8, let's say do show IPv6. Interface brief. And we're saying it's a /64:1. So we should be seeing that network right there. And we're not. Let me double check. Do show run interface loopback 1. DB8 beef 1::1. So it is properly configured. We've activated the peering under the address family for IPv6. And we've got the network statement 2001 DB8 beef :1:/64. So I'm not sure. Do show IP-BGP. Am I getting anything from... And that's locally originated. Do show BGP IPv6 Unicast. All right, so that's locally originated as well, but not being learned by San Jose 1. And that's interesting. Do show run section BGP. And I thought that we had done... I thought we did the IPv6 address family. I guess we overlooked that. I apologize. So router BGP. So we don't even have the address family configured. Address family IPv6 unicast. So again, I need a neighbor statement in here, 192.168.1.1. And we need to activate that. So yeah, so the capabilities changed, right? Which is interesting because I could have swore that we had done that earlier, which is why I was anticipating that we were going to see that IPv6 and LRI. The fact that we didn't, right, and we're kind of looking around to make sure things were configured properly, we never went into the address family for IPv6 here. So now when I say do show BGP, IPv6 unicast, now we get what we were looking for, right, which is this IPv6 and LRI, but take a look at the next hop, right? There's that : quad Fs, and then the IPv4 address embedded in there. We don't get the best greater than sign here because we cannot resolve this next hop. And the reason we can't resolve it is, again, it doesn't exist. So now let's go ahead. Now that we've seen what that looks like and we've fixed the address family on San Jose 1, let's resolve this now with a route map here. So let's go ahead and say route map next hop, and that's going to be permit 10. Set IPv6 next hop address to 2001:DB8:, and now I need to get that address off of... In fact, let me do this. I'll cheat a little bit. Say copy and paste, and then let's pull back. And there we go. So we've got our route map, and then now the route map sets the next hop for all IPv6 and LRI. So now I need to come back into router BGP 65100, address family IPv6 unicast, and the neighbor statement that we have, 192.168.1.2. And let me double check that. I'm terrible with these. Do show run section BGP. And it is 192.168. So neighbor 192.168.1.2. And again, the missing route map, the problem that I thought we had before, it wasn't the fact that the route map was applied and it didn't exist. It was the fact that the peering for the address family for IPv, I shouldn't say the peering, but the setting up the multi-protocol BGP so that the v6 information could use the v4 transport, I needed to get into the address family for IPv6 and set up the neighbor statement and activate it. And that hadn't been done. So again, it wasn't the route map that was missing. It was the fact that the IPv6 address family wasn't fully configured. All right, so now let's add this back in here. Do clear IPBGP star out. Right, and now let's come over to San Jose 1 and let's see if this looks any different. What do you think? Absolutely, right? Because now it is best, it's valid and best because I am directly connected to that IPv6 next hop address. All right, so now let's go ahead and do the iBGP pairings between San Jose 1 and San Jose 2, and we're going to use the loopback addresses as the peering addresses. So let's go ahead and say neighbor, and we'll put in the IPv6 2001 DB8 colon cafe colon cafe colon 33 colon 1. Remote AS is 65,000. So we're going to dual stack the iBGP peerings. And then we are going to have to change that update source to loopback 0. And then let's do the same thing for the IPv4. So neighbor 172.16.3.1, remote AS 65,000, and then the update source loopback 0. Now remember, there's no need for the eBGP multi-hop because this is an eBGP, right? Remember, these are iBGP peerings that we're setting up here. But what's the one thing I forgot? Exactly. I need to get into the address family for IPv4 Unicast. I'm sorry, address family, let me bail out of here. Address family IPv4 Unicast, and then say neighbor 172.16.3.1 and activate. And then, well, actually, are they having us do dual stack? So, yes, we are doing, yeah, we're going to advertise the network 172.16.2.0 with a mask of /24. But then let's back out of this and say address family IPv6 Unicast. And we are going to be doing, let's get that IPv6 neighbor statement back. Hopefully it's still in there. There we go. And then activate. And that should do it. Yeah, that should do it. All right, so we've got the address families done there. Oh, and NextHop. So again, and this is interesting, right? So remember we did it in the Cisco Learning Labs. And let me go back over to the drawing here. So which router here, router 2 or router 3, which router would we want to use NextHop Self on? Would we want to use it on router 3, or would we want to use it here on router 2? And this is an interesting question, right? Because in the Cisco Learning Labs exercises, we set the NextHop Self on both San Jose 1 and San Jose 2, or what were the two iBGP peers. But in reality, do I need to set NextHop Self on router 3? Router 3 has no eBGP peerings, right? And if it learns something from an iBGP peer, this is BGP's default loop prevention mechanism, is it's not going to turn around and advertise it back over here to router 2, right? It's not going to do that. So we don't need to set the NextHop Self on San Jose 1. I'm sorry, on San Jose 2, which is router 3. We only need to set the NextHop Self here on router 2. So let's go ahead and transition back over to the command line, and let's make sure, let me check something real quick here. Because we have a neighbor statement. Let me make sure that show IPv6 interface brief. And it is 2001 DB8. That is the loopback 0 address. Okay, so we are good there. So now let's go ahead. Don't let me forget the NextHop Self. So San Jose 1 does need to have the NextHop Self set, and do show run section BGP, and we're going to be setting that here on the 172.16.3.1 because that's the neighbor statement for address family IPv4 Unicast, and neighbor 172.16.3.1 NextHop Self. There we go. And let's also do that for, and that actually should be do show run section BGP. That should be it. Address Family IPv6 Unicast, and Neighbor 2001. Let's get this in here. NextHop Self. All right. So there we go. So we've got the NextHop Self taken care of. So now what we're going to do is on San Jose. Let me make sure I'm on step E here, where it's saying enter the router configuration mode for the IPv6 address family, advertise out the cafe :2 statement, and we've already got the... Oh, I see what they're asking us for. Okay, so we're going to get into the address family for IPv6, which we already are actually, and let's advertise out our 2001 DB8 cafe :2:/64. So we're going to advertise this network from San Jose 1 into BGP for the IPv6 BGP. So let's come over here and let's see. Do show IPv6. I keep saying IPv6 BGP. Do show BGP IPv6 Unicast. So the question is, did I get the advertisement from San Jose 1 for the 2001 DB8 cafe :2:/64? I certainly did, but what is the problem? So now we've got the problem in the opposite direction, where now over on San Jose 1, since we're advertising NLRI, I now have to create another route map. So I now need to come back in and say route map NextHop, and we leave it with permit 10, set IPv6 NextHop address to my, let me pull this back and say do show IPv6 interface brief. Remember, we're going to be setting this to our gig00, and I apologize. Got to get back on the right router here. On San Jose 1, do show IPv6 interface brief. So we're going to be using that 2001 DB8 feed 1::2. So route map NextHop set IPv6 NextHop to this address right here. Right? Remember, I'm setting it in the outbound direction so that when I router BGP 65000, so that when I'm communicating with the ISP, when my updates are being sent over there, the well-known mandatory attribute of NextHop is going to be set for the IPv6 NLRI to the 2001 DB8 feed :1::2. So let's take a look at our BGP section here real quick. And we want to go into address family for IPv4 Unicast. I'm sorry, address family IPv6 Unicast. And on the neighbor statement for 192.168.1.1, we're going to apply this route map, NextHop, in the outbound direction. So do clear iBGP star is going to refresh and resend that information. Well, actually, and tear down the, did not mean to do that there. I forgot the star out. Is going to go ahead and tear down those peerings. So now we come over and we say do show BGP IPv6 Unicast. All right, so we've got, or we have the locally originated. So now we're waiting for the update here to come in with that cafe. It should be cafe :2::/64. So we're going to have to wait for the BGP peering to reestablish, and BGP is traditionally not the fastest. And let me make sure that we've got everything set over here. Do show run section BGP. All right, and do we have, so we've got the network statement, and we've got the route map applied to the correct neighbor statement. So is it that I was just not being patient enough? And of course, BGP once again proves that it is on its own schedule, right? And it is not fast at all in terms of updates. But there we go. So we see we've got the update, and we've got the reachability that was required. We've already done the activation for the NextHop Self for the IPv6. So now it says, if the NextHop Self parameter is not used, what needs to be done to ensure reachability to routes advertised by the ISP router. And what would need to be required is if you don't set NextHop Self, you can work around that. You would just simply need to make sure that you actually have a route to the address that the ISP router would be using as its NextHop IPv6 NextHop address, which in this case, since we're on the ISP router, do show IPv6 interface brief, would be this 2001 DB8 feed : 1 address, right? Because that's the outgoing interface. So we would need to make sure we had a route to get to that address. All right, so we are now on step G, and we already did that route map, San Jose 1 becoming the route map. Now we're on step 4. So we're going to be taking a look at configuring multi-protocol BGP on San Jose 2. So we haven't done much work on San Jose 2 here, and it'll be interesting to see if they have us set the NextHop Self, because again, not required on San Jose 2. So we're going to say router BGP 65000. We're going to say BGP log neighbor changes. No BGP default IPv4 unicast. So we have to manually activate things. We're going to set the BGP router ID to the quad 3s. And now let's get our neighbor statements in here. Remember, we're peering to the loopback addresses. So we're going to say neighbor 2001:DB8: cafe 22::1 and remote AS 65000. That's an iBGP statement. And then we're going to change the update source. Whoops, change the update source to loopback 0. And then we're going to do the same thing for IPv4. So 172.16.2.1 is the neighbor's address. Remote AS is 65,000. And then we're going to change the update source to loopback 0. Now you'll notice that nothing is coming up because what do we need to do? Exactly. We need to activate these neighbor adjacencies. So address family, IPv4 unicast. And we're going to pull that IPv4 neighbor statement up again. And we're going to change this to activate. And we are clearly, I believe, going to be doing, we're doing dual stack for the iBGP peering. So we don't need to do anything sneaky here in terms of NextHop. So let's advertise our 172.16.3 network. And we've already activated with the activate statement. We've taken care of that. So let's exit out address family IPv6 unicast. And we're going to say 2001:DB8: DB8: cafe 3::/64. And then we're going to get that neighbor address back up here. So neighbor 2001 DB8 CAFE 22::1 activate. And so we've got the IPv6 pairing came up, but do show IP-BGP summary. Okay, I did not, so it shows idle, right. So it's showing idle. I did not see this pairing come up. I saw the do show BGP IPv6 summary. So I see the IPv6 summary there. And we've received 2 prefixes via IPv6. So the IPv4 is not coming up. Do show run section BGP. So this is good. We get a little bonus lab action here. So there's my neighbor statement, right? The update source loopback 0. And that looks good. And we activated the 172.16.2.1. Maybe over here, did we not 172.16.3.1 NextHop Self, and we've got the activate statement, but what's the problem? And no, we've got the update source is in there. So it's sitting in the idle state. So let's double check these IPs real quick. So do show IP interface brief. So we've got the serial interface is 172.16.1.1. And we're peering. So the iBGP peers are peering to the 172.16.2 and 3.1. And those interfaces are up. Let's take one more look. Do show run section BGP. So 3.1 should be the do show IP interface brief. Loopback 1 address here, and it is. So do I have do show IP route EIGRP? Do we have a route to the 172.16.2? Okay, we do. But do I have one over here to the 172.16.3? Do show IP route EIGRP. Whoops. And we do. So do ping 172.16.3.1 and .2.1. And I've got reachability. So this tells me it's in the BGP configuration section. Do so run section BGP. And what am I looking by here? So we've got our neighbor statement. We've got the right autonomous system number. We have the update source set to loopback 0. So that's correct. We have the activate statement. And we've got NextHop Self set. But NextHop Self isn't going to prevent the peering from coming up. So everything looks good here on San Jose 1. If I come over to San Jose 2, do show IP interface brief. Let's make sure. 172.16.3.1 and 172. Aha! I think I see the problem. I got confused. Do show run section BGP. So I'm using the 172.16s. And that's correct, though. Loopback 0. That is right. Or is it? Oh, you see what I'm doing here? I said 172.16.2.1 loopback 0, but is that the 172.16s, are those loopback 0? Or the 172.16s loopback 1? So there's my problem. I got turned around with the loopback addresses. So the peerings should be on 172.17.2 and 172.17.3. So let's go ahead and fix this. Do show run section BGP. Let's get out of the interface. We're going to say no neighbor. All right, so now we know why the adjacencies aren't forming, because that is not loopback 0. And that command should have removed the activate statement and the rest of the configuration. So let's check. Do show run section BGP. Yeah, and everything else is out of there. So here's what we need. We need a neighbor statement, 172.17 dot, and I'm on San Jose 2, so this is going to point over to 17.2.1, remote AS 65,000. Now we need the update source loopback 0. So I was simply using the wrong loopback addresses, address family IPv4 Unicast, and we're going to pull this back up and say activate. All right, so now we've got, this is sorted out here. Do show run section BGP. And there's the 172.17.2.1 activate. So we're good on the San Jose 2 side. Let's come over to the San Jose 1 side, and let's get rid of that neighbor statement there. So we're going to say no, and you can see that the peering reset. No neighbor 172.16.3.1. And that's what we want to move out of there. So there we go. Now we're going to come back and say neighbor 172.17.3.1. And let me double check. Is it 3? It should be 3.1. Yeah, it is 3.1. Okay, 172.17.3.1 and the remote AS 65,000. We've got an update source of loopback 0, now that we're using the right loopback address. Update source loopback 0, address family for IPv4 Unicast, and we're going to get a neighbor statement back and then simply activate. And now, we don't need the I, and now we should see that this peering, this iBGP peering, there we go. The iBGP peering is now up. So when I say do show IP-BGP summary, you can see that we have an iBGP peering as well as the eBGP peering. And so that is now taken care of and good to go. So how do we do this? Another way, do show IP-BGP neighbors. Right, you can see that this is an internal peering, internal link, so it's an iBGP peer, and that we are established. If we come down a little further, we'll be taking a look at the eBGP peering here, which we almost went by right there. Right, external link, meaning that this is an eBGP peering. So the question is, what is the relationship between the remote AS and whether it's internal or external? And again, this kind of goes back to the initial conversations, which is on BGP, which is if it's the same autonomous system number, they're internal peers. If it's a different autonomous system number in that remote AS statement, they are external peers. So let's see what else they've got us taking a look at here. So we see the new format for some commands. So let's get out of here. Let's say show BGP IPv4 Unicast Summary is like saying show IP-BGP summary. And so again, that's the new format, because if I wanted to say show BGP IPv6 summary, right? And again, they want you to use the unicast command here, or the option unicast when you're displaying this information. All right, so we've pretty much verified all of the information in terms of the peering. Now I'm down at step 6. We're going to be taking a look at the BGP tables. Specifically, let's go up to the ISP. Right, and this is a 1941 here. And I could say show BGP IPv4 unicast, and that's the same as saying show IP BGP. Right? So there's the 3 NLRI that we've received, or I should say that we have in the BGP local rib. Remember, this is not the global rib, this is the BGP rib, and we're learning it from AS 65,000, at least those two. The 10.1 network, remember, that is locally originated because we've got the next hop of quad zeros and a weight of 32,768. What about the IPv6 information? Show BGP IPv6 unicast. And that's what it looks like for IPv6, right? Pretty much the same output, it's just IPv6 addresses instead of IPv4 addresses. So now let's come down and take a look at a rib failure here on San Jose 1. So when I say show BGP, I'll use the new format. Show BGP IPv4 unicast, you'll notice that we see this R here, right? For this internally, or this iBGP learned information. So San Jose 1 says, I'm learning a BGP route here for the 172.16.3.0/24, and the next hop is obviously going to be that San Jose 2. The question, though, is why are we getting the rib failure? Now remember, this is the BGP local rib. This is not the global unicast routing table. And so the reason that we're seeing the R here, which stands for rib failure, if I were to say show BGP IPv4 unicast rib failure, it'll tell me that the reason there's a rib failure in the BGP rib and why this is not being installed into show IP route, why that 172.17.3 is not being installed as a BGP route. Was that right? 172.16.3. So the 172.16.3, right, as you can see here, is not being installed into the BGP rib, and it told us because of a higher administrative distance. So it was learned from an iBGP peer. What is the administrative distance? Exactly. iBGP learned NLRI are going to have an administrative distance of 200, which is why the administrative distance of 90 here on the EIGRP learned 172.16.3.0/24, that's why this is being installed into the routing table as an EIGRP route and not as a BGP route. See, the BGP route that we have is simply that 10.1.0.0 route. So if we go back over to the ISP, Evil Corp ISP router, and I say show IP BGP, or show IP route BGP, right? That's pretty much it. That's really the only NLRI that I've learned in terms of BGP. And it says, are the BGP routes learned via eBGP or iBGP? How can you tell by... I think there's a typo here. Yeah, so there's a typo in this question on step 6, part A. It says, are the BGP routes learned via eBGP or eBGP? Well, that's kind of a redundant question. So we know that they're eBGP learned routes here because, and it should say eBGP or iBGP, but it's eBGP because the administrative distance is 20 as compared to iBGP, which if I were to come over here, actually I don't know if we're going to have any show IP BGP. Yeah, there's not going to be something as a BGP route, but what we know is that the BGP, the iBGP NLRI is going to have an administrative distance of 200. And it asks the same question for the IPv4 as well as the IPv6 information. And that's pretty much it. So again, you know, the conversation about whether to dual stack or to set yourself up so you're doing v6 over v4, in my opinion, is a very easy question to answer, especially given today's hardware and the processing power and things like that. It's a pretty clear-cut case for me that I would try to do dual stack wherever I can. Because if you already have to put IPv6 addresses on those interfaces, why wouldn't you just simply go into Address Family IPv6 and establish a peering over IPv6, right? Instead of transporting IPv6 NLRI over an IPv4 session, sure, you don't have a second IPv6 session running, you've only got the IPv4 session running, but you know, you have to create the route map, right? I mean, you're going to have to create the route map, and if you're exchanging information in both directions, you're going to have to create the route map on both sides, like we saw here. And I really like the fact that this activity on San Jose 2, that it was smart enough, do show run section BGP, to show you not to say NextHop Self here in the iBGP peering neighbor statement, because it doesn't make sense. If San Jose 2 had an eBGP peer, that's a totally different story, but it doesn't. It only has an iBGP peer. So there's really no reason to set up the NextHop Self on the San Jose 2 router. Again, if we were to look here, you can see why. Or yeah, because this is San Jose 2, so I'll put San Jose 2. Right? It doesn't make sense to do the NextHop Self on the neighbor statement over to San Jose 1 because there's no eBGP learn routing information here, which it would maintain and preserve that NextHop value. So you get away with not having to do the NextHop Self. So definitely remember that. All right, well, this is going to wrap up the solution set and tutorial for BGP Lab 7.5 on multi-protocol BGP. And that is pretty much it. Remember, we do have a quiz tomorrow night. So I will see you all at 6 o'clock. Enjoy the rest of your weekend.